Imagine typing a phrase like, "An astronaut riding a horse in a futuristic city," and instantly getting a vivid, detailed image that looks like that came straight out of a science fiction movie. That's not magic, it's DALL. But how does this AI actually work behind the scenes? To understand DALL, we need to start with one key concept: generative models. Unlike traditional AI, which classifies or labels data, generative models learn the patterns and structure of data so well that they can create new data that looks like it came from the original set. DALL is a generative AI model developed by OpenAI, designed specifically to generate images from natural language descriptions. It's part of a growing family of models that include GPT for text and CLIP for understanding language and vision together. Let's break it down. DALL is based on a deep learning architecture called a Shafumi transformer. Transformers revolutionized natural language processing because they could model sequences, like words in a sentence, with incredible context awareness. The same power that allows GPT to write coherent essays allows DALL to understand and generate coherent images. Here's where things get more interesting. DALL doesn't just generate random pixels. Instead, it's trained to generate tokens, pieces of visual data that correspond to parts of an image. Much like GPT generates text one word or subword at a time, DALL generates image tokens that, when stitched together, create a complete image. But how does it connect words to images? That's where CLIP comes in. CLIP stands for Contrastive Language Image Pre-Training. It's a separate model that's trained to understand the relationship between images and text. It does this by looking at millions of image caption pairs and learning which words match which visuals. Once trained, CLIP can evaluate how well an image matches a given description, even if the image was never seen during training. OpenAI combined the power of DALL and CLIP to make the system smarter. While DALL generates candidates, CLIP evaluates which image best matches the input prompt. Think of it as a creative engine, and DALL paired with an art critic, and CLIP. Early versions of DALL used a variation of GPT-3 to generate images as sequences of discrete tokens, based on a modified version of the VAE2 image compression model. This let DALL learn a vocabulary of visual parts, like how a horse might look in different position, or how futuristic architecture is usually shaped. But in 2022, OpenAI introduced DALL-E2, which made some big improvements. DALL-E2 takes a different route. Instead of generating images directly from text, it generates something called a CLIP, image embedding, a kind of mathematical fingerprint that represents an image in a way that CLIP can understand. Then, another model called a diffusion model comes in. Diffusion models are a fascinating innovation. They work by starting with random noise and gradually transforming that noise into a coherent image, kind of like sculpting a statue out of marble by removing the randomness bit by bit. So here's the full pipeline. In DALL-E 1, the text prompt is turned into a CLIP embedding. 2, the diffusion model uses that embedding to generate an image from noise. 3, CLIP evaluates the image to ensure it closely matches the prompt. This process allows for highly accurate, detailed, and creative outputs. One of the coolest features of DALL-E 2 is inpainting. This allows users to edit parts of an image by providing a new prompt. For example, you can select a cat in an image and replace it with a dog while keeping the rest of the image the same. The model fills in the gap with content that fits both visually and contextually. There's also outpainting, where the model extends an image beyond its original borders, generating plausible new content that blends with the existing picture. This is especially useful for creators, designers, and digital artists who want to expand the boundaries of their visuals. Now you might be wondering, how does DALL-E generate images that are original? DALL-E doesn't copy or paste images from the internet. It was trained on vast datasets of captioned images, learning the patterns, textures, and relationships between objects, styles, and lighting. When you give it a prompt, it synthesizes an image based on everything it has learned, not by retrieving an existing image, but by composing a new one from scratch. Still, the process is not perfect. AI image generation brings challenges, such as bias in training data, which can lead to stereotypical outputs. Overfitting, where the model may produce images that resemble training data too closely. Misinterpretation, where the AI might misunderstand ambiguous prompts. OpenAI mitigates some of these risks through techniques like safety filters and reinforcement learning from human feedback. So what's the big deal with DALL-E? It's not just about pretty pictures. It's about transforming creativity. DALL-E opens doors for illustrators who want rapid concept drafts, marketers building custom visuals, teachers and educators making content more engaging, people with no art skills who now can visualize their ideas. It democratizes art and imagination, giving more people access to tools once limited to professionals. And as DALL-E evolves, we're likely to see deeper integration with other models. Imagine asking ChatGPT to write a story, and DALL-E generating illustrations in real time, or building immersive virtual worlds based on natural language prompts. We're only scratching the surface. So next time you see an AI-generated image, you'll know it wasn't magic, it was math, data, and a whole lot of deep learning. And behind every image is a model trained to translate words into worlds. Let's now explore how diffusion models actually work, since they're at the core of DALL-E 2. At a high level, diffusion models start with complete visual chaos, random noise. Then, step by step, they denoise the image using learned probabilities. Think of it like solving a puzzle backwards. The eye learns how to reverse the process of turning a clear image into static. And when trained well, it can reconstruct the clear image from noise. During training, these models are shown images and then taught how to corrupt them with noise gradually and how to reverse that process. Over time, they learn to generate realistic images by guessing what parts of the image should look like based on the noise and context provided. Because of this step-by-step process, diffusion models tend to create much sharper, more coherent, and more visually pleasing images compared to older GANs, generative adversarial networks. They also allow for more control and editing capabilities, perfect for tasks like inpainting or image variations. Now let's talk about image resolution and quality. Earlier models like the original DALL-E were limited in resolution. Images were low-res and often looked blurry or distorted. But Dalle 2 uses an additional model called an DALL image upscaler. This model takes the initial lower resolution image and enhances it, making it sharper and more detailed. The upscaler is trained to preserve the essence of the image while refining textures, edges, and small details. This makes the final output far more usable for practical applications, whether in marketing, education, or creative storytelling. Another incredible feature is the prompt engineering capability. Dalle responds with different images depending on how you phrase your input. For instance, a photo of a golden retriever wearing a bow tie will give a very different output than a cartoon golden retriever in a tuxedo. This is because DALL breaks down prompts into semantic components and maps them onto its visual knowledge space. You can fine-tune your outputs by being specific about art style, e.g., watercolor, 3D render, pencil sketch, lighting, e.g., cinematic, moody, soft lighting, perspective, e.g., aerial view, portrait, side profile. This ability to guide the output makes DALL not just a creative tool, but a collaborative partner in visual storytelling. Of course, this raises ethical questions. 2. As powerful as Dalle is, it raises concerns. Can it be used to generate deepfakes? Will it replace human artists? How do we ensure it doesn't perpetuate harmful biases? OpenAI and other developers have implemented guardrails. For example, Dalle blocks requests for violent, adult, or hateful content. It also avoids generating recognizable faces of public figures. Still, this technology challenges our definition of creativity. If a machine can generate a beautiful painting in seconds, what does that mean for art created by hand? The answer isn't to fear AI, but to integrate it wisely. Humans still provide the emotion, context, and values behind the prompt. Dalle is a tool, but we are the storytellers. Looking forward, what's next? Dalle is already being used in design studios, publishing houses, classrooms, and even therapy. Future versions may allow real-time co-creation with voice commands, integrate with AR/VR environments, enable cross-modal creativity, text, image, audio, and video. The line between imagination and reality is becoming thinner. In a few years, you may simply describe a scene out loud and see it appear in front of you. This is the power of Dalle. It's not just about generating images. It's about expanding human imagination through technology. And we're just getting started.